Any attacker that can position themselves in the middle between the source and destination of traffic, source being here, destination being here, can perform man-in-the-middle attacks. One such attack that requires pretty minimal skill and resources is called SSL stripping. The attacker acts as a proxy here and changes encrypted HTTPS connections to HTTP connections. And there's a free tool available to do this called SSL strip, which works with HTTP using SSL. And that's here. And this is by a guy called Moxie Marlinspike, who's a fairly well-renowned security researcher. So let's have a think about how we actually end up getting to HTTPS websites. So if I click here, now there's really a couple of main ways that we end up getting to HTTPS websites. And the first is this way. So we type in maybe the site that we're going for, and we press return. Now, most often we do not type in https://. What happens is we go to the HTTP website, and then the server gives us what's known as a 302 redirect, and then sends us to this HTTPS version of the website. Another way that we get to HTTPS websites is if you go via a link. So I've done a search here on Google, and then there we have a link, and we can see this is a HTTPS link. And then that takes us directly to the HTTPS version of Facebook. So the way SSL strip works is it acts as a proxy looking for those two types of events. So 302 redirects and links that are HTTPS. And it proxies those connections. So you send the original HTTP connection, it reaches the server says, actually no, this should be a HTTPS connection. So it sends it back. This proxies this, pretending to be your browser, and sends back a HTTP version to you. The server never knows any difference. It thinks it's talking to you. It believes this to be the browser, and what you would see would be virtually identical to the actual site. So let me show you what the Facebook website should look like. So that's the legitimate Facebook website. Now I've done HTTP stripping using Kali. And this is what the stripped version looks like. Legitimate version, stripped version. Legitimate version, stripped version. So as you can see, the difference is you don't have the HTTPS, and most people will not notice that difference. And as I said, the server never sees that anything is wrong because it's talking to a proxy that acts just like you would act. But in order to perform this attack, you need to be in the middle. You need to be able to see the traffic so that you can strip it out. And it's not always that easy to be in the middle of someone else's traffic. It really depends on where you are. So if you're on someone else's network, like for example you're at work, you're at an internet cafe, internet service provider, all those people, they control that network, so they are in the middle. So therefore they can perform this type of attack. Obviously governments, nation states, they control network devices across the internet, so they are in the middle. They can perform this sort of attack. But this is not a very subtle attack, as you can notice the missing HTTPS. But it's not beyond the government in a targeted attack that they may consider doing this, but it's reasonably unlikely, and it would very, very unlikely be done in any sort of mass surveillance type way, unless it was some sort of tin pot government that was doing it, because it's a pretty basic form of attack. Effective for low resource, low skilled attackers, but not really nation state level attack. A random cyber criminal sat somewhere at a distance from you is going to really struggle to get in the middle of your traffic. There are not really many mechanisms to do that, and it's therefore more likely that this distance attacker would attack your client instead, because that's just simply easier, and people always go for what is easier as opposed to what is more difficult. And if they attack your client and they're on your client, they own your client, they don't need to strip out SSL because they'll be able to see your data anyway because they're on your client. Another interesting way of being able to do this attack is if the attacker is sat on your local network. So that's either physically through the Ethernet cables or wirelessly through Wi-Fi. They can trick your machine into sending traffic through them. And this is known as ARP spoofing or poisoning. The attacker sends out ARP packets pretending to be the victim's default gateway. Now this works because Ethernet has no mechanism for authentication functionality, so any machine can essentially send out what's known as this ARP packet and say that they are any other machine that's on the network, including the gateway or router, which means you end up sending your traffic through a fake router, and then that forwards on the traffic and strips out the SSL, and then forwards the traffic back to you like we've shown. Now if you want to learn more about ARP spoofing, I would recommend this website here, which is quite good. And there's a little diagram here where you can see that the attacker here is saying, look, I'm the router, and the traffic is getting sent via them instead. There are tools within Kali called EtherCap, an ARP spoof, and obviously SSL strip, which can enable you to do this sort of attack. And there's a tool called Kane-Enable, which is here, which you can use on Windows. And this is the website for SSL strip, the tool. And it actually gives you the commands here for how to do this. And everything you need to do SSL stripping and the ARP spoofing, if you're local, is available within Kali. And actually here it shows you the commands that you need to run. So, and it's fairly simple. You're enabling IP forwarding here. You're making some changes to the IP table so it redirects the HTTP traffic to SSL strip. You're running SSL strip here. You need to put in the port here. And then you're enabling the ARP spoofing where you're telling the target machine to send its traffic to you instead. So if you'd like to have a play around with that in Kali, you can do that. Another interesting way of stripping out your SSL is if you set up a rogue access point, and then that can be set to automatically strip out SSL. So a rogue access point is when you connect to a Wi-Fi network and the owner of that Wi-Fi network is trying to attack you. So it's a rogue or fake access point. And you can set that access point to strip out SSL, just as we've spoke about, because again, they are obviously in the middle because that's what you're connecting to. And you can actually buy a piece of hardware that'll do this for you. And this is the Wi-Fi Pineapple. There's other versions, but this is one that I would recommend. You take this to a airport or somewhere busy, switch it on, switch on an open network saying, free Wi-Fi or something like that, and you'll be amazed at the number of passwords you'll get for Facebook and Google and all the rest of the websites by stripping out the SSL. People just do not notice. It's probably worth pointing out actually that when you do strip SSL, it means the connection is no longer encrypted, and therefore you can see all of the content, and therefore you'll be able to steal usernames and passwords and just see everything that the person is actually doing. Now, what can we do to help prevent this? Well, client side, you can attempt to notice that you don't have a HTTPS, but if you're busy, that's not necessarily something that you might spot, but you do need to keep your eye out for it. A more solid method is to use a tunnel or encrypted tunnel, so then it's not possible for them to strip out the SSL because the traffic that you are sending is encrypted by a different mechanism. So you can use SSH for tunneling, for example. You can use VPN technology like IPsec, but really what you're after is end-to-end encryption, and we're going to talk more on end-to-end encryption. And also, you don't want to connect really to untrusted networks without using tunneling or VPNs or encryption, because this is exactly what can happen if you don't have a VPN or tunneling. Your SSL can be stripped out and all your traffic can be seen. And we're going to cover more on VPNs as well. On your local network, it is possible to detect to some degree if ARP spoofing and sniffing is happening. And there's a couple of examples of tools here that you can use. This is ARP Watch. So it monitors your Ethernet to see whether ARP spoofing or poisoning is happening. And there's another tool here which is a sniffer detection, so it's seeing if anyone's watching the network traffic. Also server side, if I bring up the screen, and you may not have control of the server side, but I guess in some instances you might, you can enable, or they can enable, something called HSTS, or Strict Transport Security, which uses a special response header to tell the browser to only accept HTTPS traffic. But this only works if you visited the site before, and then your client essentially remembers that they only accept HTTPS traffic. And this is an example of where I've stripped out the SSL and I've got an error message because they'd enabled HTTP Strict Transport Security. Other ways to prevent SSL stripping and also ARP spoofing and poisoning is to use virtual LANs and other forms of network isolation. A virtual LAN prevents traffic going from one area of the network to another area of the network using a switch and special tags. If you're interested in that sort of thing, then Google around VLANs. You can also have general network isolation. If an attacker is not on the same physical network as you and the traffic is literally not going past that attacker because they're on a different switch or going through a different router, then obviously they cannot get access to your traffic. You can also use firewalls which prevent traffic going in certain directions, and you can configure Wi-Fi so that you've got isolation using the configuration on your access point, and you can set up separate Wi-Fi networks, so a guest network or network 1 and network 2, and then those two networks cannot see the traffic of the other. So there's lots of things you can do at the network layer. And when we talk about your local network and Wi-Fi, we'll go into more details on that. So that's SSL stripping.